Right. Hello, welcome to this video on lab notebooks. In this video, we will talk about what should be included in your lab notebook and how to put together your lab notebook. So to start, why are lab notebooks important? Well, they're the place where you're going to record any and all data while you do an experiment. It is also a place to record your procedure in case you need to share it with another researcher. And for if you can create an amazing invention, a lab notebook is considered a legal document and is used to help settle patent disputes. Now, for organic chemistry, we're more concerned with us just practicing how to set up a lab notebook. So what does that entail? A lab notebook consists of the following sections. You want to include your name and the date that you run the experiment, the title of that experiment, the purpose of the experiment, a reaction scheme, a chemical table, which includes hazards, chemical properties, and quantities, and a procedure. So what's highlighted in blue should all be in your pre-lab. So this is what you will turn in for admittance, turn in at the beginning of lab for admittance into lab. While you're running your experiment, you will want to continue to use your lab notebook and write down any observations and major results that occur. And then at the end, you'll also write a short conclusions paragraph. You will turn these in as part of your post-lab notebook. All right, so now let's dive into a couple of these sections a little more closely, starting with the purpose. This is essentially the goal of the experiment. Why are you doing this experiment? What are you going to get out of it? So in general, there are basically three types of processes that we're going to focus on. So your goal could be to synthesize a compound. Are you making something new from other reagents? Or is your goal to extract a compound from something else? Or is your goal to purify that compound? Now, some of these are a combination of them, and we have terms that help explain that. So some examples of what a purpose could look like include the first one here. The purpose of this experiment is to synthesize and purify acetylsalicylic acid. Synthesize is making acetylsalicylic acid, and then you're going to purify it. So I've combined the first and the second two right here into one purpose of that experiment, because that's the goal of the experiment. The second example, the purpose of this experiment is to separate caffeine from an Excedrin tablet using column chromatography. This is an extraction style experiment. You're extracting caffeine from the tablet. And this one goes into more detail by telling us what technique will be used, in this case, column chromatography. In this last example, the purpose of this experiment is to recrystallize acetanilide. This is a purification technique. Recrystallization is a purification method. And so that is the goal of the experiment. Okay. These should be generally one sentence long, quick snippets. Reaction scheme. So I wanted to highlight the reaction scheme in comparison to a mechanism, just to make sure we can understand the difference. A reaction scheme just gives us the reagents that are used to make a product. So in this example, we are combining acetylsalicylic acid with this anhydride under acidic conditions and heat. And by doing that, we now form acetylsalicylic acid. Essentially, a reaction scheme is the visual representation of your purpose. A mechanism is the more in-depth arrow-pushing explanation of how a reagent becomes reagents become a product. You can include a mechanism in like the notes section of your lab notebook, but it is not the reaction scheme that is needed in the pre-lab. The reagent table. So the reagent table, like I mentioned before, this is the area where you're going to include how much of the reagents you need. So a volume or a mass. Remember to include units on all those values. You'll want to include special hazards associated with each of these chemicals and those chemical properties. So how do you go about searching for hazards? I suggest using this website called PubChem. And let's take a look at one together. I'm going to try acetone. So that pops up. We'll click on it. You can double check that that's the correct structure by clicking on the picture. But notice immediately we have chemical safety. This is what you'll write down in your table. Acetone is flammable and is considered an irritant. If we click on this data sheet, we'll get more information such as the molecular formula and the molecular weight. Molecular weight is a good piece of information to include in your lab notebook in case you need to do some immediate conversions in lab. Again, here is our safety data that you'll want to include. If we keep going down, we'll get our physical properties, such as boiling point information, if that's necessary for your procedure, the melting point, if that's necessary, solubility, and density. Density is also a really good one to include in your notebook as well. All right. So in addition to typing out the name, there is a feature on Pubchem where you can draw the structure. So for acetone, we have a single bond, bonded there again, and then you need to make it a double bond here. Oops. There we go. And add an oxygen. And now we can search for that structure. And there it is. And it will send you to the same site. So you can search by name or by structure in Pubchem, which is really lovely. Okay, so let's go back to our presentation. Okay, the next bit is the procedure. Now, the procedure is where you probably spend most of your time. I strongly encourage you not to write the procedure from the lab handout directly into your lab notebook because there's more information in your lab handout than you need for the lab notebook, okay? Remember, the procedure should be a concise list or set of diagrams or pictures to illustrate what you're doing in lab, okay? So I took this text from one of your lab handouts. As I'm reading it, make note of which sentences are relevant procedural ones and which are more for you as an organic chemistry learner. Transfer your distillate in your container from part 1 to a separatory funnel. Add 15 mils of the organic solvent 2-butyl methyl ether, MTBE, to your separatory funnel as the extraction solvent and shake vigorously as demonstrated on video. Remove the aqueous/water layer through the bottom of the separatory funnel into a beaker. Add the organic layer to an Erlenmeyer flask. Return the aqueous/water layer back from the beaker back to the separatory funnel and extract 2 times as before with 15 mils of MTBE each time. This pulls all of the organic compounds, eugenol and acetoeugenol, into the organic solvent, MTBE. Discard the aqueous phase in the aqueous waste container. This sentence right here jumps out. So the sentence, this pulls all of the organic compounds, that's a sentence that is explaining the process, but that's not procedural, okay? There's another one, a couple sentences in here, phrases that do the same thing. That is unnecessary. You need to know that's what's going on, but that's part of the science. That's not the procedure. So when I read this paragraph, I condensed it into this following procedure, where I had steps 1 through 7, okay? An alternative method is to use little check boxes and then check them off as you go through the lab. I've seen students do that, and it's worked really well to keep you on task. Another way that you can also use to describe a procedure is using pictures or diagrams. So this diagram is saying the same thing as this procedure. Okay. So here's an example of a pre-lab from Sandy, the student. Notice we have the date, we have their name, we have the title of the experiment, and we have the purpose of the experiment, to prepare and isolate this compound. So that means we're synthesizing and then purifying. We have the reaction scheme, and we have a reagent table immediately underneath. So we have the molecular weight of this compound and the amount of grams, the mass that's needed to weigh out. We converted that into moles, and we have the boiling point or melting point for it. Notice that all these numbers have units that correspond to it. This row is for grams, except for this 1 milliliter for the water. We have moles, and we have degrees Celsius. The only not great thing is the molecular weight does not have any units. So I would have marked them as incorrect for not having units right here. All right. Another great element to include in a pre-lab is your theoretical yield. How much a material could you theoretically make given these starting amounts? Okay. And then the procedure. Notice the procedure is not written out verbatim. It's a picture. And it's very descriptive. It's basically saying you add 1, 2, 3, 4 reagents together, you reflux it for X amount of time, you go through an extraction process, you know exactly where the layers are going and what to do with them afterwards. Okay. It will take practice, but I find diagrams are way more helpful than words, but it is up to you. All right, so You're in the lab now. What are you doing? Well, you want to make observations of what's going on in the experiment. How much of the reagents did you actually add? Did you really add exactly 2.00 grams, or was it more like 2.04 grams? That's important information to have because that will affect your theoretical yield. So you'll want to include that in your notebook. Was there a color change? How long did the reaction actually take? If we look at Sandy the student, we can see that they included a time, so 10 minutes of heating, and then an observation. The solution became orange, okay? So it's better to include more information in your lab notebook during the experiment stage, the observations and results, than to have less, because as soon as you walk out, you will forget everything. You will also want to include results. So what should you include in the results section? This should be information like the percent yield. How much of material did you actually make? And maybe include that calculation. What did the product look like? In this instance, it looked like an orange solid. Include any relevant characterization data. So that could be melting point. In this case, it could be NMR data and it could be IR data. And then you will also include a conclusion. We will talk about conclusions in another workshop. So overall, some tips for success in your lab notebook endeavors. Write in pen. It'll make transferring onto the carbon copy easier. If you make an error, don't use whiteout, cross it out, and don't scribble over it. Just cross it out in a single line and write on above it. Essentially, as you're preparing your lab notebook, imagine giving it to someone else. Do they have enough information to repeat your experiment? Okay. Imagine they have the same level of education, like the same organic chemistry knowledge. Could they go and repeat it? And then, as I said before, write everything down. If you see a color change, write it down. Smell a certain scent, write it down. And then, as always, units. Every number should have a unit attached to it. On Moodle, you will find how we will be grading your pre-lab and post-lab notebook pages. This is an example rubric for the pre-lab, and there's a post-lab. These will also be available in the dry space as well for you to look at as well. Just a reminder, you will not be able to take in the lab handout with you. Everything has to be prepared in your lab notebook. There should be no extra pieces of paper flying about. Your lab notebook is what you take into lab. All right, so now let's take a look at how to use one of these lab notebooks. So we are asking you to get a carbonless lab notebook, which is a misnomer because there are carbon pages in it. If you open up, we have this third page here. This is known as a blotter. Okay, so one page. You've got this front page. This is what you'll write on. And then you now have a page immediately after it that says copy. This is the carbon copy. So what you will want to do is take these two pages, the normal page and the carbon page, flip it over, slide the blotter underneath, original page is on top, right. Okay, your ink will transfer onto the carbon copy. This is what you will turn into your instructor, and it will not bleed onto the next pages. So that's the purpose of the blotter. All right. If you have any questions, please reach out.